In this lecture video, let's take a look at properties of logarithm. So in the previous video, I mentioned a little bit of properties, so I'm going to introduce three more here. The first one here is called the product rule for logarithm. The product rule for logarithm can be used to simplify a logarithm of a product by rewriting it as a sum of individual logarithm. So what this product rule says is if I have a log with a base b of m times n. Okay, m times n is only one term. So if I have a logarithm of one term, then what we can do is rewrite it as addition, okay, as a sum of individual logarithm. So this multiplication will become the addition of individual logarithm. So that will be log with a base b of m. M go first, right? M is listed first, so m will be the log with a base b of n will be your first term, plus log with a base b of n. So the product of logarithm can be rewritten as an individual sum. Okay. So for this problem, it says expand log with the base a of 3x. So that means 3x will be 3 times x. So I can rewrite it as a log with a base a of 3 plus log with a base a of x. Okay, I can rewrite it this way. All right. Quotient rule. The quotient rule for logarithm can be used to simplify a logarithm over a quotient by rewriting it as a difference. So this division, okay, again, m over n is one term. So the division will become this subtraction here of individual. So just like the exponent rule, the quotient rule for exponents, where it's always the top exponent subtract the bottom, same thing here. The logarithm of the top here will subtract the logarithm of the end down here. So for this example I have here, I can rewrite it as a log with a base a of 3. 3 is on top, so 3 go first. Division here means I will subtract the logarithm with a base a of x. Okay, read as individual terms. All right. The power rule for logarithms is very interesting. We can actually rewrite it as a product of the exponent times the logarithm of the base. So if I have a log with a base b of m to some kind of exponent n, then by the power rule, I can write it as a product of the exponent times the logarithm with the base. So basically, I just move this to the front. That becomes n times the log with the base b of m. Okay, so this example here, I will move my exponent to the front. So that'll be 3 times log with a base a of x. So these three additional rules will actually help us. When it comes to solving exponential and logarithm equations. Okay, that I will introduce later on. All right, so let's do more expanding. Let's do more example here. Expand the following logarithm expression using the product, quotient, and the power rule for exponent. So make sure we see everything is one term inside the logarithm. So x squared times, right? So this x and y is on the top. So between them is multiplication. So that will become an addition. Then divided by z to the fifth. So that will be subtraction here. So left to right, let's do the first one. So I can write this as log with a base 2 of x squared. Multiplication here means plus log with a base 2 of y to the third. Well, according to the power rule, this exponent will eventually go up to the front, becomes the product. So what I can go ahead and write them as would these go up front. So let me erase that real quick. So I know the exponent will go up front eventually, so I can go ahead and say this is 2 times, remember this is times, log with the base 2 of x, right? Multiplication here means plus 3 times log with the base 2 of y. Division here means subtract log 5 times log with the base 2 of z. So I basically just kind of skip over one step, just go ahead and write out the answer, since this problem is not that hard. All right, let's look at this one on the right. Okay, so the top only have one factor x, so this is still one term. So this is a subtraction here in a minute. And then after the subtraction, there's a multiplication. So I'm going to write this one out for you, okay? So this is going to be log with the base 2 of x minus, okay? Now, I got to be very careful. There are two factors, okay, here in the denominator, which will come after the subtraction. So I'm going to put them in the parenthesis and say this is log with the base 2 of x minus 3 plus, right? Plus, this multiplication means plus log. Let me move this over a little bit. Plus log with the base 2 of x plus 2. So the reason why I put x plus 2 and x minus 3 in the parenthesis, because they are representing two terms, but both terms belong to the single logarithm. So that's why I put them in the parenthesis. So now with the subtraction sign here, looking at it as a -1 do a distribution, then my final answer should be log with the base 2 of x minus log with the base 2 of x minus 3 minus log with the base 2 of x plus 2. Now, this is very important that even though, see, the reason why I'm showing you this is because this is not a division and another division. The truth is, this is actually a division. Okay, if I go back to a single logarithm here in a minute, this is a division, and then after the division, the other two factors are actually multiplying here, even though by looking at the final answer, it looks like dividing again, but it's not, because between the last two terms, if I factor out a negative, that will actually become something like this up here. So with that plus sign being there, it tells me that when I go back to a single logarithm, they will be multiplying. So that means this third term actually belongs to the bottom here, okay? So you will see it here just in a minute. All right, natural log is just another logarithm with a base e. So this is actually three terms inside the natural log. So I got to make it into one term by factoring. So let me do this on the side real quick. If I want to factor 2x squared minus 30x plus 112, I will factor out a 2 first. That gives me x squared minus 15x plus 56. Factor again, the trinomial here, I will end up using 7 and 8. All right, since the last sign is positive 56, both of these will be negative to end up with negative 15. So this is basically natural log of 2 times x minus 7 times x minus 8. So now I got three different factors here. So three different factors, that will be two that will actually give me three terms of individual single logarithm. So that'll be natural log of 2 plus natural log of x minus 7. Two terms representing both of these terms belong to this single logarithm, so I got to put them in the parenthesis, plus natural log of x minus 8. All right, let me write this down real quick. Natural log of x minus 7, compare that to natural log of x, natural log of x minus 7 this way. Big difference between the two, because these two terms belong to a single logarithm. Here, I already started with two separate terms. So if it's two separate terms, that means only the x go with the natural log, not the -7. Okay, so that's the reason why sometimes you will see me write a parenthesis. Sometimes I don't, because if it's just one term, I may not write the parenthesis. But it's a good habit to write the parenthesis to indicate that both of those terms, okay, or one particular term belong to the natural log. All right, so this is my answer right here. Now this one is a little bit trickier. Let me bring it down here. This one is interesting. Got to think about the exponent rules a little bit. So on the exponent, there are 3 terms. Only 2 terms involved with natural logarithm. Okay, so how do I write this as a single logarithm term or a single term? So there's a little manipulating going on. So let's take a look at these 2 terms involving with the logarithm. All right, these 2 terms, both of them are negative. So what I can do is factor out a negative. If I factor out a negative, then that leaves me with 3 times natural log of x minus 2 times natural log of y. All right. I believe this problem actually belongs to these guys right here, because I think I'm actually trying to rewrite this as a single logarithm. So let me just look at this real quick. All right. Condense the following expression to a single logarithm where the coefficient 1 or all the exponents are positive. So I kind of misplaced this problem to here. So basically, I got to make everything back into one term. All right. So these three examples up here are expanding from one term to multiple terms. This example is taking multiple terms and put them back in one. So remember the power rule. The power rule says that the exponent got to go to the front, becomes a product. So backwards means I will take these coefficients that's in front of my natural log, put them back on the exponents. Okay, so in that case, they will look like e to the 7 minus natural log of x to the third minus natural log of y to the third. All right, so still looking at these 2 terms. The subtraction sign here tells me, oh, sorry, it's not a subtraction sign. Since I'm factoring out a negative, it's supposed to be a plus sign here. So the plus sign here tells me that now I can rewrite this as e to the 7 minus natural log of x to the third, this is a plus sign, times y to the third. Okay. All right, now the exponent on top of the e only has 2 terms. So this is where it's tricky because, okay, what in the world does this subtraction mean? Because right now I don't have a logarithm out here. I actually have an exponential expression. This whole problem is an exponential expression. It just inside my exponential expression, I have 2 terms involving with logarithm. So I can use the properties for logarithm. So right now, after I apply the property for logarithm, now I need to think about all the things that we learned before about exponents. And one of them, the exponent rule, quotient rule. For any real base a to the n power divided by the same base with a different exponent. Quotient rule for exponent says we will take the top exponent minus the bottom one, right? So now this is exactly what I have. I have a subtraction on the exponent. So that means I can rewrite them as e to the 7 over e to the natural log of x to the third, y to the third. I'm using this quotient rule backwards. Okay. And we learned before natural log and e does kind of cancel each other out. Therefore, my final answer is going to be e to the 7 over x to the third, y to the third. All right. Let's check out other ones. All right. So this is two terms with one subtracting sign. So that will become division. So there will be so these guys will be on the top. These will be in the bottom. So let's go ahead and bring the exponent back to the top. All right, single logarithm. So that will be log with the base 2 of, okay. All right, so these guys will be on the top. So that will be x over 5 to the third. Okay, divided by, or to subtract, 1 over z squared. So let's simplify this here, okay? This is a single logarithm term. So by the power rule, the top is x to the third over 5 to the third, which is 125. Is now dividing by 1 to the second power is 1 over z squared. So division of a fraction means we will times the reciprocal. So that means that z squared will go to the top, 1 will go in the bottom. So once I multiply, my final answer here for my single logarithm will be log with the base 2 of x to the third z squared over 125. Okay, so I got to simplify this a little bit. All right, this one is very interesting here. I got two terms inside the parenthesis with a subtraction between two natural log that will become division. But let's bring these two terms to the outside by distributing the phi onto the two terms. So that gave me phi times natural log of fifth roots of e to the 8 minus phi times natural log of xz. All right. Now these two phi's up front of the natural log will eventually go back up to the exponent. Subtraction sign here means division. So this is going to be natural log of, all right, this phi. So this first term will be on the top. So that will be, all right, I'm going to go ahead and do this too, okay? Converting my radical into an exponential. Denominator determines the root. So that will be e to the 8 over 5. The phi power go back to the outside. That becomes, go back to the top. So that will be e to the a over 5 times phi. All right, this is going to be xz to the 5th power. So by the power rule, if I multiply the exponent, that would just leave me with e to the 8. So this is going to be natural log of e to the 8 over xz, both factor to the 5th power. By the power rule, that will be x to the 5th, z to the 5th. Okay. All right. A couple more. This one has looked a little bit complicated, which is because you got to be very careful here. All right. 3 terms. Okay. This plus sign here means these first two is going to be multiplying. Then this subtraction sign tells you that these two will be on the top over whatever this is going to become. All right. So to write as a single logarithm with a base 5, let's go ahead, move these exponent back up to the top. So that will give me x to the third y squared to the 4th power times, all right, this middle term, 1 over y squared. All right, subtract means divide. Y to the 5th whole thing to the 5th power. All right, so to clean this up, let's do this on the side, okay? X to the 3rd y squared whole thing to the 4th power means x to the 12th, y to the 8th, right, by the power rule, times 1 over y whole thing squared is 1 squared is 1 over y squared. Still over y to the 25. So just look up here. I got 8y on top, 2y in the bottom. When they canceled out, there should be 6y left on the top, right? Over y to the 25 power. So now I got, when my base are the same and the base are dividing, we subtract our exponent, or you can just think about cancel them out. 6y on top over 25 of them in the bottom. That should leave me with 25 minus 6, 19. All right, so the 19, so there are extra 19y down here as to compared to the top. So the top will only have x to the 12. So my final answer, log with the base 5 of x to the 12 over y to the 19. That would be the answer. Okay, one more. All right, this subtraction sign, tell me I will divide. So both of them is log. So this goes on the top, which is x minus 2. I'm still going to write them in the parentheses because now you can see this is x squared minus 4, so I can actually factor this. So that will give me log of x minus 2 on top over the bottom. If I factor the difference squared, that will be plus 2 and minus 2. So when I cancel the x minus 2 out, the only thing left on top would just be a 1. So this, my answer will be log of 1 over x minus 2. Okay. All right. So just quickly kind of telling you about the three additional properties of logarithm: the product rule, quotient rule, and the power rule. And we will begin to use a lot of these rules as when we started to solving exponential and logarithm equations. All right, that will conclude this video. Thank you for watching.